Okay, arithmetic versus geometric. So, one of them, you're adding something each time. One of them, you're multiplying something each time. I'd like you to theorize which one of them feels like it should be adding. You got to pick a team. How many of you are feeling arithmetic feels like adding? You were right. That's the one that's adding. Arithmetic, adding. Geometric, multiplying. Okay, see how this is multiplying by 2 each time? That's a geometric sequence. The other is adding 2 each time. That's arithmetic. And I know it's been a few days. You know, you've been kind of out of the game. So let's see if you remember. U1 equals 5. That means we start with 5. UN equals UN minus 1. And then if I said plus 7, do you get that would mean I add 7 each time? If you understand this, you should be able to tell me the first 3 terms. Would you please find the first 3 terms? It is as simple as you might think. JP, what's first term? Hint, it's given.
5.
And then the next term. Use your fingers and toes if you want to. No, we add 7.
Oh.
12. And then add 7 again.
19.
There you go. Those are the first 3 terms. Raise your hand if you had that. Okay, good. Then let's do that's arithmetic because you're adding. Let's do a geometric. U1 equals 10. U sub n equals, you know what always comes next? Always, as in every single time, un minus 1. What it's saying is the term right in front of this term. The term right in front of this term times 3, but we put a parentheses when we're going to times something. Would you tell me what the first 3 terms are of this? J. James, what's the first term of it?
10.
Yep. And then how do I get the second term? That's a times by 3. So you just times by 3, and that's 30. Kennedy, how does it finish?
You times it again by 3 and get 90.
Yep. Does that make sense to you guys? Those are called recursive, and that's a recursive sequence. This sequence will go on and on and on. The first one's called U sub 1, the second one's called U sub 2, etc. If you pick a random one out of let's say that later on it was 120 and 240 and 360. I'm adding 120 each time, by the way. Looked like I might have been timesing by 2 at the beginning, but I was actually adding 120 each time. Is this arithmetic or geometric? This is the kind where you add, so what's it called? Arithmetic. And I know you're thinking of the word arithmetic. That's back in elementary school. When you're doing this unit, it's called arithmetic. And I know it feels wrong to say a word differently than you've always said it, but I know it's spelled the same as arithmetic, but you say arithmetic. This is an arithmetic sequence. Would you please write the equation? It starts with U1. I'll pause for a second. Okay, so we're going to start with U1 is 120. And then this is the next line. You always write this. U sub n, which is like any random term. Like say I pick this one, U sub n. I pick that one. Pick any term you want. It's given by U sub n minus 1, which is like the term right in front of it, except you got to add 120. So we put plus 120. Does that make sense to you guys? Then I introduced, on the last day we had class right before the weekend, I introduced this concept of n, which is the little sub numbers, you know, like this, like this, like this. N has to be greater than or equal to 2. That's called a domain. You will have to write one of these on your equations. Otherwise, you'll lose a minimum of 5% off if you don't include that. And I know I haven't been stressing that, and I know most of you didn't put it, but would you please go put it right now? Put it in with your equation that you just wrote. Because without the domain, without this, you won't get credit. It's an integral part of the problem. What it's saying is that it only works starting on n is 2. Think about that. N is equal to 2 is the smallest it can be, which means this will not predict the first term. The first term, how can you get the first term? Do you go to the term in front of that? No, there isn't one. So recursive sequences have a hard start, and they do go on forever, but you can't like make up a number that existed before this. So this only works to predict the second term and the third term and the fourth term. So it's saying n has to be at least 2 or this equation won't work. And if that was too complicated for you, just always say n is greater or equal to 2. That's all you gotta write. And it means the second term is where this thing starts working. So if I said like, I'm not telling you the first term, when you can't do these. Knowing that you add 5 each time doesn't help unless you know the first term. And will our formula predict our first term? No. So, in other words, if I had just this part, can you tell what the first term is from that? No, you can't. See, this formula does not tell you the first term. That's why you always got to say at the end, n has to be greater than or equal to 2. N are the sub numbers. And n sub 1, we don't know. U sub 1 has to be given. You have to tell us, oh yeah, start with a 7, and then we'll add 8 each time. 7 plus 8, 15 plus 8, 23, ... But you can't tell what the first term would be. That's what this is saying. I almost wish they said n cannot equal 1, because then it would be like, this won't work for the first term. But it's kind of like that, saying n has to be 2 or bigger. Right. Arithmetic or a special type of sequence where each term is equal to the previous term plus a constant. You know that number we keep adding? It's called the constant. And it's called the common difference. I almost wish they called it a constant difference. But the common difference, C4 is the common difference here. And you might be like, that's not a difference, that's an add problem. You're right. Differences are subtract problems. So you go 9 minus 5 and it gives you 4. 5 minus 1 gives you 4. Difference, subtract. 17 minus 13, it gives you 4. So this is the difference. Difference means subtract, and the common difference was 4. What's common difference here? Well, I know it's subtracting 2 each time. Is 18 minus 20 negative 2? Look at that, the common difference again. The difference means subtract. 16 minus 18, it's negative 2. So negative 2 is the common difference. Whereas if you're doing geometric kind, where you're timesing by 3, then this divided by this, 6 divided by 2 equals 3 is the common ratio. Did you know that a fraction, when you have two things divided, that means a ratio? It's pretty much the same thing as a ratio. So the ratio that they all have in common is that if you take this divided by this, you get 3. This divided by this, you get 3. 162 divided by 54, I'll trust them. I don't really know, but if I used a calculator, I bet it would be 3. The common ratio seems to be 3. Okay. Here's the ultimate test. Do you understand these words? If you do, you can write an equation where you go u sub 1 equals, and then da 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 da. See if you can write the equation for this. I'll pause for a second. It's a typical test question. Here we go. U sub 1 is negative 12. Good job. Keep going.
Yeah, and then it's un equals un minus 1 plus 5.
Common difference is plus 5. Plus 5. And then what's that little domain thing that I said is going to be worth at least 5% on the test?
It's greater or equal to 2.
N greater than or equal to 2. Yes. That's going to be really annoying, and you're going to forget it. And if you do, you're going to lose 5% at least. So please, double check for that at the end. Yes?
So do we just have to like write that on the side?
Yep, just write it off to the side. It's kind of like in more complicated math formulas where you go like this. They'll often say something like, oh, by the way, a cannot be 0, because you're not supposed to divide by 0. And so they'll say this like, hey, you can't do that, by the way. So same thing. It's like, hey, this only works for n is 2 or bigger. That's another way to say that. U sub 1, it can't know that, because that's the starting term. And just because I say like, hey, you're going to add 5 each term, that doesn't tell you where to start. So this formula only works for n is greater than or equal to 2. Okay, write a recursive formula where the first term is 20 and the common ratio different. That's a different type of question. Still u sub 1 equals, still u sub n, still u sub n minus 1. You know what? That's in every single formula, and I can add something to that. Every single formula always says n is greater than or equal to 2 on it. Now, all you got to do is figure out what goes here in the red question mark and what goes here in the blue question mark. That's really it. So, Connor, what's the first thing? The red question mark. What is our first term?
0.4.
Nope. Read it closer. What's the first term?
Oh,
20. And the 0.4, be careful with that now. Should I add 0.4, subtract 0.4, multiply by 0.4, or divide by 0.4? You put it in parentheses. I'll give you that hint. Does that make you think add, subtract, multiply, or divide?
Multiply.
Yep. That's a multiply. There's your answer. Do you get that the black part of the answer would have always been there, no matter what the problem had said? They always have these pieces. In a contract, if you were a lawyer, they would say that's the boilerplate. It's like it's in every contract. Every contract always has to say who the two parties are that are going into the contract. If it's me and Tesla, because I'm buying a Tesla, then the contract will be between me and Tesla. And then I agree to do a certain thing, and they agree to do a certain thing. Like I might agree, I'm going to spend this much money, I'm going to give it to you. And Tesla might agree, in exchange, we are going to give you this car and this software and agree to support that car until its death. You know, because if they just gave me the car and said, nah, we're not going to update the software, that'd be pretty bad, because then, you know, car doesn't work one day and all of a sudden I can't fix it. So I'm sure in the contract it says that they'll give me the car and support the software for as long as the car, maybe they even have a year on that. Like we'll support the software for 20 years or something like that. Okay. So in a formula, the boilerplate is this'll always be there, this'll always be there, and this'll always be there. Do you get that really only means you have to figure out two things? It's like you got to figure out where does it start and what do you do each time. And this is a common ratio question, which told me it was a geometric. So here's the words you got to know. Common ratio goes with geometric. Common difference goes with arithmetic. Alexis, could you shut that door? It's getting a little loud for lunchtime out there. Okay. Now, this is something, there's an exception to every rule. U1 versus U0. I just got done saying that U1 is how we're always going to start. And it's kind of like other things in life where you say, would you agree if you're telling a first-time driver, you would say, you always want to keep the car between the lines on the highway, right? First-time driver, you're going to say that. But isn't there always exceptions? Like, well, if there's a car coming at you head on, you better go across those lines and get out of the way, right? Or if there's a person standing in the road, you're not just going to hit them and say, well, you told me to keep it between the lines. I couldn't go across the line. So there's always an exception. My point, we usually start with u sub 1, but we can start with u sub 0. If I said u sub 0 equals 5 and u sub n equals u sub n minus 1 plus 6, what would be different? Well, it's kind of the same thing. I still start with 5. It's just that that's called u sub 0. And when I do add 6 and get 11, that'll be called u sub 1. And isn't it a little weird to start with 0 instead of 1? Yes. So when would you ever do this? Would you agree that an experiment that you start right before the experiment starts, that's at time 0. We can't call the start of an experiment 1 second. There's a gap between 0 seconds and 1 second. It's actually a fairly long time in photography. Do you think that the aperture on your camera stays open for a whole second? No, it gets over with in less than half of a second. Like probably less than a tenth of a second. It just goes super fast, but it takes some time. My point is that if you're starting an experiment, you start it at time 0, and after 1 second, maybe the temperature's already gone up because you're heating this thing and it starts at whatever temperature, but then after 1 second, it's already changed. So sometimes we want to start with u sub 0 when there's an experiment. So if we were going to do an experiment and say, I'm going to keep a heater on this vial of liquid, and you're going to keep heating it until it gets to like 400 degrees. You're going to start at some point, and after 1 second has gone by, it'll be hotter than it was before. So we have to start at time 0. So that's why you sometimes start with u sub 0. And all that means is that the first term then isn't called u sub 1, it's called u sub 0. That's our first term. This is the second term. Even though it's u sub 1, it's still a second term. I know it kind of freaks you out a little bit, but this is called the first term, whether or not you start with u sub 0. The problem will tell you, or you'll know because it's an experiment or a real-world scenario. All right. Looks like a real-world scenario. A concert hall has 59 seats in row 1. So imagine for a moment, this is our concert hall. There's a whole bunch of seats here. And I'm not going to be able to draw out enough X's to make it actually 59, but there's 59 in this row. And in the next row, a whole bunch of seats, it's going to be a little bigger. If you've ever seen a concert hall, it can get bigger like this, or it can anyways. This one's 63. This one's 67. Are you noticing that it's like a sequence where we start with 59, it goes to 63, it goes to 67? What's happening each time? Between 59 and 63, how much is that? Adding 4. How much does it add this time? Then that's what's called a common difference. It sounds like something I could write an equation for, doesn't it? In fact, let me just do that. It'd be u sub... I'm going to choose u sub 1 for the first row. That feels like it makes sense to me. Row 1. Otherwise, how the heck am I going to do row 0? That'd be weird. So I'm going to say U1 is 59. UN equals UN minus 1, and then I add 4 each time. And if they asked me like, hey, how many are there in the 10th row? I could say it was 59 first, and then I add 4 is 63, and then I add 4 is 67, and then I could just keep doing that until I found the 10th one. I showed you how to use a calculator on that, right? You go 59 plus 4, enter, plus 4, enter, and now your calculator knows, oh, he's done it twice in a row. I think he's going to keep adding 4. And you just go enter, 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 enter until you finally get the 10th one. But you've probably been suspecting that there's a faster way to do that. You will see. All right. So here's our recursive formula. Is this arithmetic or geometric? Say it. Come on. Arithmetic. Yep. Because you're adding 4 each time. How many seats are in the 5th row? Well, that's 3 rows, so I can just go 2 more. Now let me ask you, what if you had to do this and find the 25th row? I'd use a calculator. Now, is there a faster way than with a calculator? There is, but it involves something kind of complicated. And I'm not sure which way we're supposed to go with yet, so I don't want to launch it and tell you some complicated way, and then there's 2 ways you can do it. I don't know which way we're going to use for our test, so give me time. Eventually, I'll show you the fast way. But if I just keep adding 4 here, 71, 75, there's 75 seats in that row. Okay. I'm going to give you this hint. You usually start with u sub 0 or u sub 1. You always have un equals un minus 1. And then if you're multiplying by something, it goes here. Or if you're adding by something, it goes there too, but it doesn't have parentheses. Read this scenario and see if you get it. I bet you'll figure out what to start with. I'll bet you'll figure out whether you multiply or add. I bet you can do it, because there's really only 2 things left. The blue question mark and the black question mark. I'll pause for a second. I want to see if you can do it. All right, so let's see. Arithmetic or geometric? Well, it looks like they were going increasing by 2%. I call that multiplying by 1.02. Did you already forget last unit? That would have been times by 1.02. Starting at $79.99. How many of you figured that out? Raise your hand if you did. Okay. And I bet some of you knew it was $79.99, but you weren't sure exactly how to do the 2% thing. Does that make sense to you now? Is it arithmetic or geometric? Well, you're timesing by something, so it's geometric. And there's our formula. Ooh, I keep saying this. No, not you. What's the domain thing you got to have at the end or you lose 5%? N is... It's easy to forget, isn't it? I bet. Did anybody have that? Anybody in this whole room? Nice. 3 people. Cool. All right. Careful with geometric. Increase means the numbers need to get bigger, so that the common ratio needs to be bigger than 1. See, what a lot of people put is 0.02 in there. If you actually times by 0.02, it's going to shrink a lot. So you need 1.02, not just 0.02. That's what they're trying to say there. Common mistake is to say just 0.02. Wrong, 1.02. Even better, 1 plus 0.02, but it's the same thing. Okay, I feel like you understand it. I checked your homework. There's only one problem that I feel like would be logical to chop off at the end. Chop off the last question. Find your homework if you haven't already. I know some of you started early, which isn't a crime as long as you're still paying attention. Kennedy, can you read me the first problem? Numero uno.
It's 6, 11, 16, 21.
Did you catch what they were doing each time?
It's adding 5.
And is that a common ratio or a common difference?
Common difference.
Yep. And what do they actually ask you about this problem?
Is it arithmetic or geometric? And then common difference or common ratio.
Oh, okay. So arithmetic, is it an A or a G? What do you say?
Arithmetic.
I agree. And what is the common difference? I'm going to call it the CD.
Plus 5.
Yep. You can say plus or you can just say 5, as long as you didn't mean minus. So like positive 5, we usually can just say 5. there any other parts, or just that?
It's just saying the value of common different ratio again.
Okay,
Just the 5.
and that's the 5. All right. Okay, I think you're getting the idea. When would you ever use U sub 0? If you're doing an experiment or in some real world problems. If you start with U sub 0, it just makes it easier to understand that, like, when we started our experiment, the Tesla bot was able to last for 4 hours before charging. But after 1 hour, he had 3 hours of charge left. Started with 4 hours of charge. After 1 hour, he has 3 hours of charge. You see how then starting with U sub 0 would make sense if you were doing an experiment like that? Okay. All right, that's all I have for you for today.